off we go. So let's finish up these slides today. It'll be some fun stuff. Or we'll almost finish the slides. Let's say that. So let's see here. Let me make sure I am where I want to be in all my notes and things. Yes. So yeah, we stopped last time just learning how to iterate through stuff. We went through a whole string, we lowercased it. It was very fun, but we learned about while loops and for loops. Let's do some cooler loopy stuff. I want to teach you some keywords in C++. They're called continue and break, and they help you do loopy things. And oops, this notes page that I have over here is not loading. There it goes. So yeah, let me show you these two things. So continue and break, you just say them by themselves, like continue, semicolon, break, semicolon. They only work inside of loops, but if you're inside of a loop, you can use either one of these, and here's what they do. Continue skips a loop iteration. It's like, I want to just go to the condition to the top of the loop to start a brand new iteration. I don't want to continue, or I don't want to do the rest of the body. I just want to jump right to the top. Do the next iteration of the loop. I'm done with this one. Okay? So let's use a for loop as a demo for continue. Let's say that we're printing from 1 to 10, but we secretly hate the number 3. So we don't want 3 to be printed. We just want to skip that one. So we're going to use continue to make sure that happens. All right, so let's go to some code. Oh. Let me get in the right spot here. Slowly but surely. And then what are we today? We're lecture 7. Make a folder for us. All right. And so, if this ever wants to load, I'll make a new file called continue and break.cpp. Don't know why that's there. There we go. Okay, so let's say I have a for loop and I'm printing from 1 to 10. So for int I equals 0, or I equals 1, I is less than or equal to 10, I plus plus, that's how it's ranging. C out I. And right now, it's printing all the numbers from 1 to 10. We don't like that. G++, continue and break, dash O, continue and break. So let's say that we have a grudge against the number 3 for some reason. You can use continue to skip that iteration. So here it is printing all the numbers from 1 to 10, including 3. But if I hate 3, I can do this. I can say if I is 3, if I is 3 and I'm about to print it, don't. Continue. On a line by itself. So this skips the rest of the loop, if I can spell, and goes to the next iteration. So it just jumps right up to the loop top, and it's like, all right, I plus plus, make it 4, is 4 less than or equal to 10. It does it all in the right way. So this skips over the printing of 3. It goes to the right back to the top and does the rest of the loop. So here, if I run this, there it is, 1, 2, 4. Yay, so that's continue. Any questions about that? It's just a little keyword you can use when you're inside of a loop to skip that iteration. Do the next one. Oh, what's up? Oh, thank you. Thank you very much. I didn't even notice it. All right, so that was continue. Let's do the next one. The next one is break. This also works only in loops, and this is if you're done with the loop. You're like, you notice that you want to stop the loop now. Break stops the loop. Stops the closest loop you're in, which is foreshadowing for what we're about to talk about. But let me show you a while loop to stop when the user types Q or something. Let's say that we're getting a bunch of characters from the user and doing something with them. Let's use a while loop for that. So let's just, until the user types Q, do something. So let's make an infinite loop while true. Condition is always true. Let's keep on asking the user for stuff. Enter a character or Q to quit. And until they type Q, just keep doing this stuff. Try to C, get it from CN, and then, I don't know, just like print it back out to them, do something silly. You typed your character in a new line. So this loop would go on forever right now because it's infinite, while true, yeah? There's no way to stop it, unless you use break. You can use break to stop the loop whenever you want to, if you notice that you need to. So we're going to have the user type Q to quit out of this loop, and so if that C that we just got from them is equal to the magic Q quitting character, then break. This is going to stop the loop. So the loop has the potential to go on forever if the user never types Q, but once they do, it's going to stop. So break just stops the loop wherever you are. All right, so enter a character A, B, C, D, and you type this, blah, 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 E, you typed E, F, G, and then you can keep on playing this game all day until you type Q. And Q goes here, and then it breaks out of the loop. So it stops, goes right to the end, and then that's the rest of the program. All right, any questions about break? Those are two useful things to have in your arsenal. So those are those. Let's see here. Let's do cooler loopy stuff. Let me do a complicated example. This is the mathematical formula for the constant E, which comes up a lot. I'm sure it's like 2.71 whatever. Here is a formula for it. It is the infinite summation. Maybe we haven't seen this before. This just means sum all these things. When n starts at 0, let n be 0, let n be 1, let n be 2, and add all these terms together. So it's like 1 over when n is 0, 1 over 0 factorial, plus 1 over 1 factorial, plus 1 over 2 factorial, plus 1 over 3 factorial, until the end of time. Keep doing that. It converges to E. And so 1 over 100 factorial is pretty darn small. It's smaller than we can fit in a double. So let's just, let's go up to n equals 100, and let's make a loop that calculates E. This summation notation, by the way, is just a mathematical for loop. So it's kind of funny. So let's see here. All I'm going to do is I'm going to make a sum variable. I'm adding a bunch of things up together. So I'm going to start at 0.0. And then I'm going to calculate my current term. I'm going to have an n inside of my loop that I'm ranging over things with. And it's my current term of my summation that I'm calculating. That's equal to 1.0 over the factorial of n. 1 over 0 factorial, 1 over 1 factorial. It's 1 over n factorial as n ranges from 0 to 100. 1 over factorial of whatever n is right now. That's my current term that I want to add in. Fill that and just put it in there. Just keep on adding a bunch of those terms. That's kind of how the loop's going to be. So that is my fun example for us. Let me do the scaffolding, and then I'm going to have to write a factorial function secretly, and you can look away because I haven't taught you that yet. But it's good practice. So let me make a new file called e.cpp. Why not? So here's the idea. I have a sum variable that's eventually going to hold the sum of these terms. It's going to start at 0. It needs to have decimal, so double. Then for every term, 1 over, 1 over 0 factorial, 1 over whatever factorial. So n for int n equals 0. That's the first term. N starts at 0, and then n just keeps getting bigger. 1 over 1 factorial, 1 over 2 factorial. So let's go up to n equals 100. So n is less than or equal to 100, n plus plus this time. It's getting bigger. And so every time I have a new n, I have a new term I need to calculate and shove into the sum variable. So this one, then this one. Just put them all in there. So what's my current term? It's 1 over the factorial of n. Double current term equals 1 over factorial of n. And then once I have that, I just add it into the sum. Sum plus equals current term. And remember that this syntax is short for sum equals sum plus current term. Just faster to do it that way. And then after this is done, I have a sum sitting in my sum variable. That is E. It's a very close approximation for E. Pretty much perfect as far as doubles are concerned. Yeah, so the last piece of the puzzle is this factorial function, which does not exist in the CMath library or anything like that, so I have to make my own. So you can look away if you would like to. But I guess, first of all, does everybody understand how this is going to do what the slide was saying? We're going to add up the first 100 terms, n ranges from 0 to 100, calculate each term, put it in the sum variable. Do we see how that kind of matches this? assuming we've seen this syntax in a math class before. All right, yeah, so the last piece is a factorial function. Let's make it happen, and I have to make sure it returns a double. We're working with large numbers right now. So, again, I have not told you how to write a function yet. That'll be future slides. But I guess this is good practice showing you that's not too hard. How do I write a factorial function? Well, it's called factorial. It takes a number, what do I want the factorial of, has a body, what do I want to do, and it's going to return a double. It's going to give me back a double, the factorial of n. Usually a factorial is a whole number, but I have to use double because it's going to be such a large number it wouldn't fit in a normal int. So okay, I have a result that I need to give back. Result I'll start at 1 because I'm going to multiply a bunch of things in. So result is going to be the answer eventually. And all right, what do I do before I give back the result? Well, I have to multiply. What is the factorial of n? It's n times n minus 1 times n minus 2 times n minus 3 all the way down to 1. Or the flip side, it's 1 times 2 times 3 all the way up to n. So I'm going to keep multiplying things into this result variable. That's how you do a factorial. For int I equals 1, I is less than or equal to n, I plus plus. So just keep on multiplying result equals itself times I. Just a bunch of multiplications. That is a factorial. So if I give it if I ask for the factorial of 5, it will calculate 1 times 2 times 3 times 4 times 5. Just put them all into result. Okay, so that's a factorial function. And we give back that answer. Again, I haven't taught you that yet, but hopefully it makes at least a little bit of sense. But now we can do what we set out to do. e.cpp-oe. And with the default precision that we get when we print things out, this is perfectly precise. 2.71828, that is the number e. And we just calculated it. Cool, from scratch. Any questions about that? How fun. So that's that one. That's a fun example of loops. Let's see here. We've talked a lot about loops now. It's your turn to give this a try. So please go to the Written Ice page, get into peer instruction groups, and here is your challenge. And I'll stop this once we're done, so please do attendance. I'll clear it out for us. Boop. All right. I would like you to come up with a good example of an infinite loop, all right, in your group section of the Written Ice page. You can work together if you'd like. But try and write the most subtle infinite loop you can, all right? This will help you learn about what infinite loops might look like and how they're hard to track down. All right, so this is good practice. Come up with an infinite loop, a loop that never stops, and try to make it as subtle as possible. All right, take a couple minutes to try that. Help each other. So you're intentionally messing up right now so that you don't mess up in the future. It can be a for loop, can be a while loop. It cannot end. So if it can't end, that means the condition of never be false. Always. Doing already. Another few seconds. Maybe Maybe like start with printing from 1 to 10 or something and like mess it up. That's one way. That's my timer. Is that enough time to think of something and try to get it down? Let's see. I see. Oh, it looks like we do have some stuff. Nice, nice, nice. So yeah, while true, that's never going to end. Good. That is not very subtle, though. That is always not going to end. Let's see. Ooh, I like this one a lot, group 65. If you start a number at 5 and it always gets bigger, you keep checking, hey, is it ever going to be 4? Maybe you, yes, that's very nice. I like that a lot. Good, good, good. Well, I is less than 1. I minus minus if I starts at 0. Very good. Yeah, so you kind of, if you get that condition flipped from what it maybe should have been, that's one way to do it. Oh, nice, group 68. This is essentially while true, so not very subtle, but you know the secret that you can leave some things blank. So you're a very good programmer. Yeah, so flipping that condition. It's always going to be greater than or equal to 1. It's going up. Good, good, good. Yeah. Any questions about this stuff? This is making some sense. So this is stuff to watch out for, right? When you're writing your own loops, then now you know better. Okay. So thank you for that. All right, back we go. Oh yeah, exactly. Very good point, Robert. So yeah, if you ever forget, like if you're checking for equality, remember to check with 2 equal signs. Otherwise, you just made sure it was equal. You just set that value, and it gives back whether it was truthy or not, and usually it was. Nice. All right. I just have a bunch of cool examples for us today before we get into something complicated. So one last one. Let me show you how to use loops to animate things, because like what is animation but showing, like, have we made a little flip book in elementary school when we were bored before? Or is that not a thing anymore? So like all you do, like all a film is, right? You show a single frame to somebody, and then you wait a little bit and you show them another frame of the movie. And like if you do that fast enough, it's animated. That's all animation is. So let's make a loop that like prints stars, and if we use that pause function that I have from the very first lecture, that karaoke example, if we use that pause function to have C++ wait before it runs the next iteration of the loop, then we won't see a bunch of stars immediately, but they'll like take time, and so it will be animated. All right, so let me show that to you. Okay, so I don't know, I'll call this animation.cpp. Good enough to me. And then I need that pause function that I had to look up, so don't even worry about memorizing that. But it was from the karaoke.cpp file. There's all this stuff. Whee! It stops the program for a certain number of seconds. That's all it does. Don't worry about it. But I can use it now that I have it. So I don't know, let me iterate 10 times. So int I equals 1, I is less than or equal to 10, I plus plus. That's going to run its body 10 times. As computer scientists, it's less typing to do it this way. We like to iterate from 0 up to 10, and that's also going to iterate through its body 10 times. If you're not using I, that's the normal way that I like to do it. It's like, iterate 10 times, please. I do it like that, starting I at 0, strictly less than. So let's print a single star character and a new line, but wait in between calls. So like pause, I have that now. Wait for half a second before you like continue and like start running the next iteration of the body. Wait, that's what pause will do. And so now it's not going to print 10 stars immediately, just like in the blink of an eye, we see it happen. It's going to produce animation. 1 star, 2 star, there they go. And so it's like animated, pretty. It might look a little bit cooler if the star is being like whisked away to the right or something. So there's a way to do that if you add spaces. Let's add I spaces before every star in our loop. So here's like, I don't know. Here's a way to duplicate a bunch of things. So you can use the word string, like the type name, and call it like a function. And that will create a special string for you if you call it with the right stuff. I want to make a string of I space characters jumbled together. If it's 0, it's nothing. But if it's 1, it's like create the string that has 1 space character. If I is 5, create the string that has 5 space characters. So watch what that's going to do. Kind of cool. It's like a little, like some snow being drifted to the right in the wind or something. I don't know. But that's animation. You can write cool things. There's cool stuff on the internet to look up now. So that's my last cool example. Any questions about that? So yeah, if you just make different frames and you show those to users for different amounts of time, that's all animation really is. So, oh god, it requires the C++ version of the time library, so that's Chrono. This is stuff that I don't teach in any CSCI class here. It's fancy, C++. I had to look it up. Yeah. We don't even teach multi-threading in lower division, so like that doesn't even make any sense to anybody who's been through our classes. You'll have to wait till a 4-year college to fully understand this code, but I'd be happy to explain it to you in office hours. Alright, so yeah, that's animation. Awesome. I do now need to teach you something that is a traditionally difficult concept for CSCI 40 students. So here, warning signs, maybe pay a little bit of extra attention than usual. We have loops. Loop bodies can hold arbitrary code. Why can't you put a loop inside of a loop? That's called a nested loop. All right? You totally can. So, oh man, you knew this was about to happen. This is just the logical next step. So let's go here. So you can do this. You can put a loop in a loop because what is a loop but just code? So you can put code within code. It's fine. So, all right, here's the secret. Here's how I want you to think about it. This will make no sense the first time I say it. It will take a million examples. But here's the thought process. During each iteration of the outer loop's body, so like this outer loop is like, all right, my condition is true, I'm going to run my body. It's going to run all of its body, which involves running an entire loop. The inner loop is going to run completely once during each iteration of the outer loop's body. It's like, all right, I'm going to run this entire loop. Then, all right, if I'm true again, I'm going to run this entire loop again. So the loop, there's nothing secret about it. It's just naturally what's happening, but it's weird to wrap your mind around, all right? So like if I ranges here in this while loop from like 1, 2, to 3, to 4, to 5, and J ranges in this loop from, I don't know, 0, 1, 2, 3. For each value of I that this loop runs its body on, J ranges between 0 through 3. Then it goes to 2, and then J has a chance of being all of these all over again. Because this whole loop is code, and it's got to run to completion before this whole body's done. All right? I know I can only say the same thing so many times, so let me give you an example. All right? Here's some code that kind of does that. It's a for loop. It's a nested for loop. And here's its output on the right. Try and see, as I'm explaining it, why this is the output we see. All right? So, okay. Here is the outer loop. It's working with an I variable, and it's ranging from 0 to 4, right? I goes from 0 to 4 because it's less than 5, strictly less than. And so it's going to run its body. This outer for loop is going to run whatever between its two braces 5 times. Executes its body 5 times. Right? I hope that makes enough sense. So whatever's in its body, it's going to run 5 times just by this setup for the loop. All right? Now here's an inner for loop. It's working with J. It's making J go from 0 to 4. Again, it's going to execute its body 5 times. Do we see that? Also executes its body 5 times whenever it runs. And it's going to run multiple times because it's the body of another loop. Okay, so that's a little complicated. Let's see here. So that means, let's see, how do I want to say this? Let me just walk you through this code now, and we'll try and watch it work. So here's the innermost body's code. It's outputting both I and J. Let me try and walk you through why we're seeing this exact output. Okay? So I starts at 0. That's what a for loop does. It starts as I at 0. Is I less than 5? Sure. So it's going to run its body, which is another for loop. So we have to run this entire for loop now. All right, and j equals 0. Here's j. Started at 0. Is 0 less than 5? Sure it is. All right, it's going to run its body. So now the very first thing we see printed is 0, 0. I hope that makes at least a little bit of sense. That's the first one. So that's why we see this. And then we're working on this loop, right? It's got to run to completion before we're done with the body of the outer loop. So, all right, j plus plus. J is 1. Is 1 less than 5? Sure. Run the body. So I has stayed 0. J is now 1. So it prints 0, 1. See how that's working? Please yell at me if you have questions about this stuff. It's hard. All right. J plus plus. We're still working on this loop. It's not done. It's the body of the outer for loop. It itself is another for loop. So is 2 less than 5? Sure. Run the body. Print 0, 2. So I is still not changing. We're working on this thing right now. We're looping through this. It's running its body 5 times before we ever give up. Right? 2, 3, we see 0, 3, 0, 4 is 4 less than 5. Sure, 0, 4. And now finally, j plus plus, make it 5. Now we're done because the loop is over. Right? So this entire loop is completed. And so we hit the end of the body of the outer for loop. And to run a loop just means, all right, I plus plus, check your condition. Now we're on I. Also, j only exists for this for loop. So right before it finishes, j gets deleted. Now we're just working with I again. Now we jump back up to the start of the outer loop. So now that we were here, now we do I plus plus. Hey, is 1 less than 5? Sure. Sure it is. So we'll run the body again. So again, we run the entire inner loop because it's just the body. It's the body of the outer one. Is that making slightly a little bit of sense? So now we have a new j. J equals 0. All right, is 0 less than 5? Sure. Print I and j. Now I is 1 and j is 0. That's why we see this output. Kind of getting it? J plus plus. We're just working on this loop now. Is 1 less than 5? Sure. Print 1, 1. Print 1, 2. Print 1, 3. Print 1, 4. That's the last output we see. And then we're done because we make j 5 and it goes away. But I think you get the idea. And then we go back and we do I plus plus again. And so we do like 2, 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 3, 0, blah, blah, blah. 3, 1, 2, 3, 2, 3, 3, 3, 4. Then I gets to be 4 and j ranges from 0 to 4 all over again. 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. That's why we see it, and that's the order we get it in. Okay? So every time this loop runs its body, as long as I is less than 5, it's going to do this entire piece of code, which is itself a loop. It's going to run it to completion. So that's what I meant by the box on the previous slide. All right. Any questions about that? So it kind of makes sense why we see that output in that order. It's very important to understand. Also, since we know that this executes its body 5 times, and every time it runs its body, it's going to execute another loop that itself runs its body 5 times, how many times does this inner line run? Does anybody know? Can you see the math involved there? Yeah. Good. Yeah, it's 25 because, all right, this is it's going to run its body 5 times, which is going to each of those 5 times run this loop, which iterates 5 times. So it's 5 times I'm doing this for every 5 values of I. So 5 times 5, we get 25. So this line gets executed 5 times 5 equals 25 times. And so if you're confused about what the output might be, at least you know you're going to see 25 lines somehow. Okay? So that's pretty cool. So there's a lot to unpack from this loop here. Hopefully it makes a little bit of sense, though, as we're starting out. So, okay. First cool thing that we noticed is the second cool thing, but I'm going to talk about it first. It's easier. This 5 times 5 business. It's going to execute things 25 times rather than just a normal 5. So here's one key idea of nested loops. Put a loop inside of a loop that's going to multiply work that you're doing. Okay? Suddenly, this was happening 5 times. So you put it inside of another 5 times loop. Now it's 25 times. We squared it. So, okay, let's use that to our advantage. Let's draw some stars. Let's draw a box that looks like this using a nested set of loops. All right, and here's the setup. I'll show you how naturally nested loops fall out of this. I'm going to have two loops. The first loop is going to worry about what line we're on. All right, so there's going to be two loops. There's going to be an outer loop and an inner loop. Outer loop, an inner loop. And here are their jobs. So the outer loop will worry about which line we're on. That's what it's going to care about. And then the inner loop is going to worry about, all right, we're on this line. What do I got to do? Print that line of stars. Okay, print a single line of stars. That's what the inner loop is going to worry about. Print a single line of stars. And so here's how I want you to think about it, how to break down this problem, and how two nested loops naturally fall out of this. How would you notice that there's repetition going on? We need at least one loop here, right? Because I need to 4 times draw a line of stars, right? I need to 4 times do this exact thing. 4 times do one line of stars, a second line, a third line, a fourth line. So that screams loop to us, right? Maybe not nested loop yet, but here's the English version of that. Here's the recipe. So do 4 times the following. Print 4 stars and a new line. So do we see how this will create that if this were C++? Because 4 times, print 4 stars and a new line. That will give you this box. Yes? And now notice that this print 4 times is also looping. 4 times you're printing a single star. See that? So, all right, let's transform this whole thing to, all right, the outer do 4 times. All right, do 4 times, print 4 stars and a new line. All right, so I can break that down into another do 4 times, print a single star. And then after I'm done with all that, I'm ready to print a new line. I'll unindent, print a new line. Do we see how this code follows from this code and will create this box? Assuming this English was C++. It's called pseudocode. It's not real code, but it's good enough for us. So do 4 times, print 4 stars in a new line. We can split that up further into, all right, 4 times, print 4 stars in a new line. But what is printing 4 stars but 4 times printing a single star? All right. So that's the secret, and this will translate into a loop. So let me exactly copy this code. I'll translate it into some nested loops. Box.cv. So here it is. So I need to do 4 times. So let's make a loop that executes its body 4 times. So for int I equals 0, I is less than 4, I plus plus. I'm not even going to use I. I'm just using it to iterate. I'm making sure that it's going to run its body 4 times. So that's what this one's going to do. Execute the body 4 times. All right, and then what do I need to do? I need to print 4 stars in a new line. That's my job in the body of this loop. And a new line. If I were to do that, doing that 4 times makes a 4x4 box. All right? And now I can break that down. What does it mean to print 4 stars? Well, it means to 4 times print a single star. In j equals 0, j is less than 4, j plus plus. See out a single star. So this is going to print 4 stars, and then I'll print my new line. I guess I was writing \n in the example, so I'll keep it \n here. That is the code. That was this all over again. And of course my Zoom window's in the way. There we go. Do 4 times, print star, print new line. So that's all it was. So execute the body 4 times so I can make four lines total. And then the job of the body is to print 4 stars in a new line, and I hope you see that it's doing that. This will print 4 stars, this will print a new line. It's just natural that we need a nested loop here. And there we go. There we see our 4x4 box of stars. How pretty. Are there any questions about that? And it's going to take a second to wrap your mind around, I know. Here's the code. Now I have a question for you. You don't have to write this down anywhere, but I want you to try it on your end somehow. Take my code. This printed a box of four stars, 4x4. Oh shoot, what did it do? Take this code, connect to the server or something, go somewhere so you can write code and have it run. Modify it to print a 4x4 hollow box of stars. See if you can figure out what's going to need to change here. This is a hard question, but just by thinking about it, it will help you, even if you don't get it in time. Right? So I'll give you a few minutes. Give this a try. Help each other. And see if you can print a hollow 4x4 box of stars using a nested loop. So you're going to have to change some stuff, right? You can't always print 4 stars in a row, only on the top and bottom lines. How will you know you're in the middle? We've got plenty of time. I want to fiddle with this comment. It's not 4 stars on a million. Do one thing or another, depending on where you are. Wink, wink. Alright. So that's my timer. There's a million ways to do this, but here's the way that I thought of in my mind first. And it's probably the easiest to explain. You're going to need an if else, right? Because sometimes you're printing a star, sometimes you're printing a space. So that's going to translate into an if else. So here is the secret. Just taking this code and like thinking about what's going on. Let's think about where we are for like I and j. Like when we're working on this line, I is 0. That's the very first iteration of the body of that outer loop, right? So I is 0 when we're on this line. I equals 0, and then it like prints a whole line, does its stuff. So I will be 1 on this line, 2 on this line, and 3 on this line. I hope we see that, because the outer loop is worrying about which line we're on. Here is 1, I is 2 when we're working on this line, I is 3 when we're working on this line. And then if we're in the inner loop, each time we're on a line, it's like j is going to range from 0 to 3, right? And we're printing stars, but we have to like change this to something else. Sometimes we want to print spaces, so let's notice when we want to print stars versus when we want to print spaces. So regardless of which line we're on, we're printing this character when j is 0, printing this character when j is 1. You see how that's the second character as the loop is ranging. J is 2 when we're printing this character, and j is 3 when we're printing this character. So let's put all that in. So j is 0 when we're printing this one, regardless of which line we're on. J is 1, j is 2, and j is 3 for that one. Okay? And that kind of tells us, when do we not want to print a star? We want to not print a star and print a space instead when I is 1 and j is 1, when I is 1 and j is 2, when I is 2 and j is 1, and I is 2 and j is 2. You see that? Every other time I want to print star. But these special combinations of I and j, that's when I want to like not do the star printing, but print a space instead. Right? You could also check other ways, like check for when you want to print a star versus when you want to print spaces. But this is shorter to type those conditions, but it's going to be an if-else. All right? And I hope you see that. That controls whether we want to do one thing or another. And so it's going to be like if I is within this range and j is within this range. Like one way to write this in math would be like if I is between 1 and 2 and j is also between 1 and 2, that's going to put me right in the middle there. So if I is between 1 and 2 and j is between 1 and 2, in math you can write this. I need to show you in a second why you can't do this in C++. And j is between 1 and 2. But if you could write math in C++, like this would be the condition for printing spaces. I hope you see that. Okay. Any questions about this? This is when I want to print a space. Every other time I want to print a star. That's important to notice. All right. And so sadly, you can't like translate this to code very easily. It's got to be like the and would be the ampersands, of course, but like this you cannot write in C++. You can't like translate it into 1 less than equal to I less than equal to 2. This does not work. In Python it does, but not in C++. You have to translate this into like, is this true and is this true to get both sides. All right. If you draw the parentheses, you'll kind of see why. But this has got to translate into, is 1 less than or equal to I and is I less than or equal to 2. That's how you give this range. Is I bigger than or equal to 1? Is it less than or equal to 2, essentially? Right. So now our if statement that will control whether we print a space or a star will look like this. It's got to be like if I is within this range and j is within this range, then we got to print a space. So if, let's do it backwards. If I is greater than or equal to 1 and I is less than or equal to 2, so it's between 1 and 2. And then also the same is true for j. If j is also bigger than or equal to 1 and less than or equal to 2, if all that's true at once, then we must be in here. If that's true, then space. Else, keep the star. Right? That's going to be how that works. Any questions about this? So this is going to control, based on I and j, whether we print a space or a star. And let me code that up for us so that we have it. So I'm taking what I had before, and I'm going to mess with it. So I would like to not print 4 stars in a new line anymore. I want to check to like in the body here, instead of printing a star always, I want to sometimes print the star. So I want to check to see if we're in the middle. So if all this stuff, if I is greater than or equal to 1, and it's less than or equal to 2, so it's between 1 and 2, and j is greater than or equal to 1, and j is less than or equal to 2, so if all that's true at once, it's within that range, then it was a space, not a star. So make it a space, otherwise it's time for star. So if we're in the middle, print a space, otherwise print a star, and then we have printed 4 characters one way or another after this inner for loop is completed. We're ready to break the line. Okay, and let's put a new line in between these 2 boxes so that it looks prettier. And here we go. So definitely study this code so you understand why it's working. Maybe run it through that C++ tutor website that I talked about before. Very helpful. Watch all the variables change. But there's your hollow box, 4x4. Any questions that come to mind immediately about this? This is something we just have to stare at for a while, maybe. All right. I promise it'll start making sense. Let's see here. So that was a fun little example. Let's move on, and here's one for you. Let's have a example where I draw not a box but a triangle. A triangle of stars. So it's going to be like a right triangle. It'll be leaning to the left. So that's what it'll look like. But we're going to do the same thing. It's almost a box. It's half a box. So it's going to be very similar, but watch what's going to happen. So like the outer loop is going to govern like which line we're on. So I equals 0 on this line, I equals 1 on this line, I equals 2 on this line, I equals 3 on this line. But the body of that inner loop has to be the same code repeated. How do I, in the first iteration, print 1 star, second iteration, print 2 stars, third iteration, print 3 stars, fourth iteration, print 4 stars? So I have to repeat code in the body that always does the same thing. So it's always going to be draw blank stars. And repeat that. Draw blank stars on the second line. It's got to be the same code that does it. Does anybody see what I can put into both of these blanks? It's got to be the same code. That will print 1 on this line, 2 on this line. Good. So do you see how we could use I? We haven't been using I here. I guess we're checking it here. But for the box, it's just use it to iterate 4 times. Use this to iterate 4 times. We weren't using I and j in the actual code. Now we can use I to determine how many stars we want to print. So notice how, like, if I is 0, we want to print I plus 1 stars on this line. That'll make 1. When I is 1, we still want to print I plus 1 stars. And so that's the code that we can repeat, because that'll make 2 when we're here. See that? Any questions about that? Because that's a cool new jump to make, and that's going to help us. So draw I plus 1 stars every time. So let me steal most of this code, and we'll make a new file called triangle.cpp. And so instead of printing a box, I'm going to almost print a box. All right, so it's going to execute its body 4 times, but it's not print 4 stars in a new line. It's print I plus 1 stars and a new line. All right. So this body right now is executing 4 times. So it'll print 4 stars. I want it to iterate I plus 1 times. So it'll print I plus 1 stars. Do you see what I need to change? It's just this. Like, this makes it iterate 4 times. If I just make this 3, it'll iterate 3 times. 2, it'll iterate 2 times. If I make it I plus 1, it'll run I plus 1 times, whatever that is. Depends on I. So our inner loop depends on the outer loop, finally. That's pretty cool. And so now, oops, if I can get to the terminal, I see a triangle of stars, and isn't it pretty? So see if you can kind of understand it. Like, when I is 0, all right, I'm going to iterate this body. J starts at 0. J goes until J is strictly less than I, which is 0, plus 1, so that's 1. So it's going to only iterate once, printing a single star. But then when I plus plus, I is 1, it goes 4, j equals 0, j is less than 1 plus 1, so 2. So it'll iterate its body 2 times and print 2 stars. When I is 2, we're on this line, we want to print 3 stars. So I plus 1 is 3. J goes from 0, strictly less than 3. 3 stars printed total. Kind of see how that's working? I swear you need to use this website if it's confusing. Search for C++ tutor, go there, and be like, all right, I don't understand. Paste, visualize. This is the greatest website ever. It's like, all right, in the body, I is this. We're about to make a j. I is 0. All right, j is 0 as well. What's I plus 1? Okay, that must have been 1. So it's going to execute its body, and now j plus plus, and it skips the rest. Just does it once. New line. You can just watch it work and how the values of I and j change. You can watch it print a single star at a time. So please use this. I think it is helpful. All right, so that's enough of me trying to convince you of that. So that's triangles. Do you see how that's like the next step up from boxes? You're using the inner loop and you're controlling it with the value of that variable that you're making in the outer loop, because it exists. It exists throughout its body. Of course, it exists inside of whatever you're writing there, even if it's another loop. So that's pretty cool. Are you happy with that? Because that was all key idea 1, right? I need to show you key idea 2. This was nested loops multiply work. That was the idea of multiplying work. If you have 2 loops, each running like 5 times, this will happen 25 times. There's one last thing that I haven't shown you, key idea 2, and that was having to do with that output that we saw for that example. Nested loops are going to try every combination of values. Do you see how this was doing that? It was trying every combination of 0 through 4 for I and 0 through 4 for j. Do you see how it's running through each of them? They all get a chance. That's the other thing that nested loops are good at. They try every combination of I and j. See that? I stays 0, and then j goes from 0 to 4. I is now 1, and j goes from 0 to 4. I is now 2, j goes from 0 to 4. It's going to hit every possible pair of those 2 numbers. Okay? I hope that's making some sense. And so that's why we see that output. And that lets us solve some cool problems. So a silly problem that I have for our example is an example of a brute force algorithm. It's just like you're throwing a computer at a problem because it can execute things so quickly. A brute force algorithm just tries every possibility to solve whatever problem you have, and it just doesn't try to be smart about it. It just tries every possible thing. And our computer can do a few billion things a second, so it works out just fine for smaller problems. So here's the problem that I'm going to solve with this idea of nested loops trying every possibility. I'm going to range over every possibility. So we are let's pretend that we know a farmer, and she goes to a market, and here are the prices of things at the market. You could buy a horse for $10. Pigs are cheaper, they cost $3, and then rabbits are on sale today for 50 cents. So we know that this farmer bought 100 animals, and she spent exactly $100. That's the story she told us. And we know the prices of all these. So now our question is, how many of each animal must she have bought? There may be multiple solutions. So that sounds like a job for a triply nested loop, because I'm just not even going to try. I'm going to throw the computer at the problem. I'm not even going to think about it. I'm just going to make 3 variables, like she could have bought how many horses? She could have bought 0 horses all the way to 100 horses. I'll just make a loop that ranges over every possibility. Or, how many pigs could she have also bought? Num pigs. I'll make a num pigs iteration variable. That she could have bought 0 pigs, or she could have bought all the way to 100 pigs. Maybe 50. I don't know. Somewhere in between. So I'm just going to make another loop inside of that loop that ranges over num pigs. And then num rabbits. She could have spent all her money on rabbits. So 0... could have bought 0 rabbits or 100 rabbits, because we know that at most she bought 100 animals. All right? Or exactly, she bought 100 animals. So that's that screams like I got to range over all these three possibilities, and nested loops do that. So I'm going to make a triply nested loop, to try all those combinations, to try all the combos of those three numbers. Like the first iteration is going to be like buy 0 horses, 0 pigs, and 0 rabbits. 0 horses, 0 pigs, 1 rabbit. It'll take a while to get the right thing, but it's like the right thing is somewhere between all of this, right? Maybe it's 50 horses, 25 pigs, and 25 rabbits or something. That is a possible range, right? We're going to range through every combination of those three numbers, each themselves ranging from 0 to 100. So this is a brute force algorithm because we're not really thinking about the problem. We're just throwing the computer at it. Here we go. Brute force.cpp. All right, so let's do horses first. Why not? So the farmer could have bought 0 horses all the way up to 100 horses. So what are all the possibilities? So int num horses equals 0. It could go all the way to 100. Num horses plus plus. Okay, so that's going to let num horses range from 0 to 100. And then while we're ranging those, let's range over pigs. Because like you bought some horses and then also some pigs. So I'm going to make another nested loop. So now instead of horses, it's going to be pigs. Num pigs ranges from 0 to 100 as well. It's another loop, so add another body for that. Does that make sense? So we're ranging between 0 through 100 horses, and now we're also ranging between 0 through 100 pigs if we're in the body here. Does that make sense? And then we want to do the same thing for rabbits. We want to range over all the rabbits. So one more triply nested loop. So I want to replace this with rabbits. There. And so now, when we're in this body, when I am here, C++ is trying all the possibilities, so it's ranging over everything. When I am here, I've chosen, right? C++, we're speaking as if we're the computer, I guess. I have chosen some amount, like there's a valid value between 0 and 100 for all these things, for horses, pigs, and rabbits. I have chosen some amount of horses, pigs, and rabbits. I don't know if it adds to 100 or not. We gotta check that. So every possibility is gonna get a chance, all the way from 0 horses, 0 pigs. Oh, of course. Oh, it's 3. Yeah, of course. It's been an hour. So let's click the button. Thank you. Sorry. So much suspense. I'm sorry. This is like the coolest part of the lecture. Just remember it in your mind. Come on. You can do it. I'm gonna have to. My team must be getting sick of me by now. That's it was. Let's try it one more time. If not, there's another way to connect. Probably, honestly. Okay, sure. I just had to do it the hard way. Okay, so where was I? So when we are here, in this body, we have chosen some amount of horses, pigs, and rabbits. It could be 0 horses, 0 pigs, and 0 rabbits, which is not a valid solution. Or it could have been 100 horses, 100 pigs, and 100 rabbits, which is also not a valid solution because it's supposed to add up to 100. But somewhere in between, like we're going to get every range, right? Go from all those, from 0 of them to 100 of each of them. But in here, I have some valid value. I have some value for horses, pigs, and rabbits. I've chosen that. Every possibility is getting a chance. Every possibility will get a chance. Okay? So we're trying to solve this problem. And it's like, all right, the farmer bought 100 animals and she spent $100. So now we have to check, like, was this particular amount of horses, pigs, and rabbits, was that even 100? So let's like, int num animals. How many animals did we just buy? Num horses plus num pigs. Oops. Num pigs plus num rabbits. There. So that's how many animals we bought. And then we also wanted to make sure that the farmer, if this was a solution, the farmer would have bought them for $100. Let's make the price as well. What was the price of these whatever animals we bought? Well, it was the horses times their price. So horses were $10 a piece. And then pigs, how much were they? They were $3. And then rabbits were 50 cents. So that's the price I spent on all these animals, and that's how many animals I bought. So now this is a solution to this. If num animals is 100, and the price was also 100. And remember how I told you that you should never check a double for exact equality? I'm going to break that rule right now because I am the teacher. Okay? Do not break this rule until you have a degree in computer science. I know that it's going to work. All right. So if this is true, then that's a solution. Right? I can't even show you everything right here. This is so large. If all that's true, then I have found a solution. What was it? Oops. There. I found a solution, print it out. So this was a valid solution. They add up to 100, and it was $100 total. So see out. All right, this is how many horses you should have bought. Num horses. Comma space. And then buy a bunch of pigs. Let's see if I can make this somewhat pretty. Num pigs. And then buy num rabbits. And that's a solution. And then a new line for that one, and that can be the end of it. All right, so there's the code. Trying every possibility of horses, pigs, and rabbits ranging from 0 to 100. A lot of these are not going to be solutions, but eventually, num animals will be 100, price will be 100, if there's a solution. Here's how you notice the solution, that if statement, and then we'll print out one of the satisfying values of that solution. All right, so let's run. In the blink of an eye, we run how many things, right? This is ranging through 100 times 100 times 100. That's 10 to the 1, 2, 3, 4, 5, 6. That's a million, right? A million possibilities in the blink of an eye. The computer is so fast. But apparently, here are the there are two solutions to this problem. You could buy 0 horses, 20 pigs, and 80 rabbits. So that's 20 pigs for $3 a piece. So that's 60 plus 80 times 50. Yeah, that adds up to 100. Or you could buy 5 horses. That's 50 plus 3, so 53. Plus, I assume this is going to add up to the right answer, 47. Yeah, $47 for those rabbits. So that adds up to 100 again. And of course, it's 100 animals total. So in the blink of an eye, we just threw the computer at a problem, and it ran through a million iterations of this inner body, super fast, and it came up with the answer. Are there any questions about that? I found 2 answers. And I think that is all. No, I can't even show you the last curly brace unless I zoom out. Any questions about that? So this is the second cool thing that nested loops are good at. They can multiply, or they can try all the possibilities, okay? But at the expense of multiplying the work. Okay, so that's fun. If you are like a stats major or good at math, you will notice that I only really needed a doubly nested loop, because the second you've made a choice for horses and pigs, if you want it to add up to 100, you know how many rabbits to buy at that point. So there's 2 degrees of freedom to this problem, and I didn't need to range through the rabbits, but this was more fun. Easier to talk about anyway. So you could make this slightly more efficient, but that's where I was going with that. And so, if we are happy, are we happy to move on to the last couple slides of the day? That was a cool example, I think. Let's stop with this idea, because this is what I want you to get good at, as usual. I want you to be experts at running code in your mind, because That's how you become a better programmer. That's just the truth. So I want you to be able to look at code like this and draw a diagram for exactly how it's going to run. All right, so let's do that flowchart thing again. So this is like a line, before and then after. Pretend those are lines of code. So we start at before. And then we have this nested loop. All right, so just think of it in pieces. How does a while loop execute? How did I tell you? So it's always going to check the condition and then run the body if it's true. So it's always condition, body, condition, body. That's what gets looped until the condition is false. All right, so as long as the condition is true, the first thing as long as the condition is true, it's going to run the body. So the very first thing the while loop does is, well, figure out, do I need to run the body? Check A. Check that condition. A question mark. Is it true or false? If it's true, it'll run the body, which is going to be this giant for loop. If it's false, we're done, right? If it's false, the entire loop is done. We skip the body, which means skipping that inner loop, and we go straight to like the after part. So here's after way down here. Does that make sense? That's false. Go straight there. But if it's true, we got to run its body, which involves running a for loop. All right. So the for loop has 3 pieces up top. How does it execute? This is the initialization part. Then the condition, then the increment, and then here's the body. What's the order? It's always initialization happens once and only once. So that's the B part. That's the first thing that happens when we're running this for loop. And then it's always just like kind of like a while loop. It's always check the condition. If it's true, run the body. After the body's done, do the increment. That's what's being looped. And then check the condition again. As long as the condition is true, it's going to run the body and the increment. As long as the condition is true, it's going to run the body and the increment. That's the order. So the for loop is now ready to see if it's ready to run the body. So it's going to be like C question mark. It's going to check its condition. If it's true, it'll run the body and then the increment. So if it's true, it will, let me get my zoom window out of the way. Oh, my poor computer. Why can't it check that? Here. Move down, please. All right. If it's true, we do the body. That was E. And then we do the increment, which was D. And then we go right back to the condition. So that's what it means to be a loop, right? Go right back to the condition. Like, keep on repeating. Condition, body, increment. As long as the condition was true. So as long as it's true. The second the condition is false, we are done with the loop, right? The second this condition C is false, we are done with the loop. So false. Or let me not draw the end of that line because something's got to happen. Once this is false, we are done with this loop, and we go to like the ending brace, which means we've completed one iteration of the while loop. And the while loop was always worrying about check its condition, run its body as long as it's true. So we've just run the body of the outer while loop. We have to go back to the condition now of that outer loop. Can't forget about it. So once we're done with the inner loop, we're ready to try the outer loop again. That's how that loops. So it's like going to do this a bunch of times, and then eventually it's false and it comes back. It's like a figure 8 almost. And then I believe that's all the options. So we got true, false everywhere. They're all going somewhere. That is how this code will execute. It's a little tricky. It's something I want you to practice, though. Are there any questions about how I read this off and explained it? All right. Here's a fun little meme that you can look at that kind of highlights everything we learned about today. It's like the ultimate peanut butter and jelly sandwich. If you put rows of sweet things and then rows of different kinds of peanut butters or Nutella, then you have 9 options total, right? It's a nested loop at that point. So give that a try maybe. Now you know. Now you can program this. All right. So with that, that's all that I got for us today. Let me stop recording before I forget.